Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Walker Middle School. And in this video, we're just going to be working on some surface area and volume of some cylinders. And so make sure you're using those formulas at the top for yourself. So again, as a reminder, again, those formulas for cylinders are going to be as follows. We're going to say surface area is going to be 2 times pi times the radius squared, plus 2 times pi times the radius times the height. Anytime we do surface area, it's always going to be units, so whatever the units are to the second power. However, for volume of a cylinder, we're going to say that it's going to be equal to pi times the radius squared times the height. And when we have volume, we're going to be talking about units to the third power, since we have those third dimension. Talking about cubic units. So in the first one, we're just working with some surface area first. And so we're going to say, okay, find the surface area, make sure you label first. And so, well, when it is referring to a point or a line segment from the middle of a circle to the edge, we're going to say that is going to be our radius. So we're going to say radius r is going to be 6. Then we could say, well, what other attribute do we need, or what other dimension? Well, we need the height. We can say that is going to be 4. So our height is going to be 4 for this one. Make sure we use the right formula. So I'm going to say surface area is equal to, well, what do we have? We have 2 times pi times the radius squared plus 2 times pi times the radius times the height. Plug in your values for your variables. So we have surface area is equal to, use parentheses to show multiplication. We'd say 3.14. Make sure that exponent is inside the parentheses, so we can say our radius is going to be 6 squared, and then we have plus, and then we have 2 times 3.14 times the radius, which is 6, times our height, which is 4. Again, anytime I use parentheses, I am just showing multiplication. So again, make sure that you are seeing those similarities and those differences. So now we can simplify. And so again, make sure you can evaluate those expressions carefully. So we're going to say, all right, 6 squared is going to be 36. 36 times 2 is 72. So we have 72 times 3.14 is going to be, so we're going to say surface area is equal to, all right, we have the area of our bases, which is 226.08, plus the area of our lateral surface. So we do 2 times 6 is 12, times 4 is 48, and then we can do 48 times that 3.14, and so we're going to get 150.72. Let's actually write 2 there. 72, all right. Make sure you can add those 2 together, and so we're going to say surface area of this cylinder, even though this is a net. Again, that's a net. That just means it is, that 3D figure laid out on a 2D plane. So we're going to add those 2 values together to get our grand total of 376.8. And we're going to say what our units are, kilometers. So we're going to say kilometers to the second power, since we're talking about surface area. Excellent. For the next one, still using surface area. So make sure you can label the 2 things we need. Again, you always want to make sure you're saying, okay, what is it giving me? What do I need? So it gives me the height and radius, and that is what we need. So we are good. So let's say our radius is going to be 6 again. So we say our radius is 6, and we can say our height is going to be 10. Still using that same formula, we have surface area is equal to 2 times pi times the radius squared plus 2 times pi times the radius times the height. Substitute in your values for your variables, again using parentheses to show multiplication. Again, I just let pi be 3.14, so that way it's a little bit easier to work with. So then we have plus, and we have 3.14 times 6 times 10. So now, again, we can still simplify. we actually have this value is going to be the same. So we actually know that even though these look different, we're going to say the area of the bases are actually going to be the same. So that means this. 2 times 3.14 times 6 squared is going to be 226 again, 0.08. And we have to now do, let's say 6 times 10 is 60, times 2 is 120. And so I can say, all right, 120 times 3.14 is going to be that 376.8, which actually, hey, that is that same value we got before, but you want to make sure you're doing all the steps carefully. So we need to actually add these two together. And you noticed, hey, our height is different in these cylinders, so our surface area is definitely going to be different. And I'm going to add those two together, and so I'm going to say 226.08 plus 376.8 added together is going to be at 602.88. You're going to have those units squared, so we're going to say inches squared. Again, we said that we had R as 6 inches and H as 10 inches. All right, moving on. We can do this last one, make sure it's on the screen here. That should be fine. So now we can say this. We can say, all right, let me actually zoom. All right, so we can say find the volume. However, what does it give us? Well, we know we need to have that radius and we know we need to have a height. However, what does it give us? We're going to say that this is going to be diameter, which is not what we need. We need the radius, so we know that the radius is equal to the diameter divided by 2. And so we're going to say the radius is going to be 8 divided by 2, which is 4. So we're going to say 8 divided by 2, which is 4. Then we could say 20 centimeters is going to be our height. So we'd say 20 centimeters is our height. Now we can use that formula that we have at the very top here. We can say we have volume is equal to pi times the radius squared times the height of that cylinder. Substitute those values in for those variables, and so you have 3.14 times that radius, which we said is 4, so we're going to say 4 squared and have that exponent inside of the parentheses. Then we can say times our height, which is 20. Now you can simplify. We can do this. Let's do 4 times 4 is 16. Then we have 16 times 20 is 320. Still multiply that last term. So we have times 3.14. So we're going to say the volume of this cylinder is a grand total of 1004.8. Again, have those units. We said centimeters. Since it's volume, we have centimeters cubed. So we're going to say that that can fill over 1,000 centimeters cubed. For number 4 on the back, since it's a word problem, you want to make sure that you can read it carefully for yourself and then pull those parts out that you do need. And so we can say, all right, a round swimming pool has a diameter of 15 feet and is 6 feet tall. How many square feet would it take to enclose the pool? And it says find the surface area. So if you want to, you can draw that picture. I personally like drawing the picture, but that is up to you. So I draw a circle. I have those sides. It's not going to be perfect. I am not an artist, barely a mathematician, but that's okay. So we have our swimming pool. It says it has a diameter. So when you have that diameter, it goes the whole way across, and we're going to say that's 15 feet. I'm going to say 15 feet. However, remember, we need radius. Let me make sure it's not too slanted here. We need radius and we need the height. So if our diameter is 15, that means our radius is going to be half of that. So we need to take 15 divided by 2, which is going to be 7.5. So we're going to say our radius is 7.5, and we said it is 6 feet tall. So we're going to say, all right, this is going to be 6 feet, which is our height. So now we can say 6 feet is our height. make sure we have that surface area formula, because that's what we're talking about. We're trying to enclose this pool. Maybe we need to move it, or turn it into a fish tank of some sort, maybe a shark tank, but we can definitely have that formula down. So we're going to say surface area is equal to 2 times pi times the radius squared. Let me actually double check. Yes, that would be the area of the bases. So that's the area of the bases, and we need the area of the lateral face of that side part. So we're going to say, let's have 2 times pi times the radius times the height. Substitute in those values for those variables, and so we have 2 times 3.14 times the radius squared, so we're going to say 7.5. Be sure to have the exponent enclosed, meaning inside the parentheses, and now we can have the rest of it. So we're going to say we have 2 times 3.14, and we have times the radius times the height, which is 6. All right. And if you ever need to, make more room for yourself, that's totally fine. That's why you have an eraser. Make sure you take a deep breath, exhale, be patient with yourself. So now we can evaluate or simplify this expression. So I'm going to say, all right, surface area is going to be as follows. So we're going to do 7.5 squared, 7.5 squared. So we're going to say that's 56.25 times 2 times that 3.14. So our first value that we have here is going to be 353.25, but we need to include that lateral face. So we're going to do 2 times 6 is 12, and we can do 12 times 7.85 times that 3.14. So we're going to say, all right, this is going to be 282.6. Make sure you can add these two together to get your grand total. And so we're going to say, all right, I have 282.6 plus that 353.25. So we're going to say 635.85. And what do we talk about? We said this is going to be feet, surface area, second power. Lastly, make sure you can see and apply this one as well. We're going to say, all right, for number 5, it says that the fire extinguisher has a radius of 4 inches and is 12 inches high. How many cubic inches can it hold? That means we're going to find the volume. All right, so we need to find and have our radius, and we need to have our height. We can kind of draw it out. It's going to be a little bit rough, but that is okay. I'm going to say, all right, we have our fire extinguisher. Hopefully it doesn't look like that. It has a nice hose on the side, but I'll let you draw out those details. So we're going to say the radius of that extinguisher is going to be 4 inches. So we're going to say our radius is going to be 4 inches, and our height is going to be 12 inches. So we're going to say H is 12. I'm going to use that volume of a cylinder formula. So we're going to say volume is going to be equal to 2 times pi. Actually, let's back up. Let's double check. You know what? Maybe I kind of forgot what it is. Let's go to the front. What did we say it was? Well, when we find the volume, we need to have pi times the radius squared times the height. So again, I want to make sure I have that. So let's say pi times the radius squared times the height. Again, everybody makes mistakes. That's what's making us human. So now I can plug in those values for our variables, and we can have 3.14 times the radius squared. So we have 4 squared, or raised to the second power, times the height, which is 12. Be able to simplify carefully. So we can do 4 times 4 is 16. And we do 16 times 12 is 192 times pi, which is 3.14, is a grand total of 602.88. Again, we're talking about cubic inches, so we need to have inches to the third power. Again, be able to take time for yourself and make sure you see these items. And as always, super slam that subscribe button.